So let's get down with the example, actually. PowerShell. So we want to basically fix the stuff in the cost function. So where was I? I was a VQLS, and I will just do Jupyter Notebook. Wow. I think I know where the problem is. I think I know what the problem is. Yeah, let's open these. Good. So I think if I, hopefully the sound will stay on. I think I think the problem was here. So when because I was getting really big numbers, and I think, because when I'm getting the counts, I'm really getting the actual counts, and then so if I'm doing like 1,000 shots, those things kind of add up to 1,000, basically. So what I should do is, I should basically, that is really probably a hacky, and I shouldn't do it like this. But life is short. Do not do it. So I think that could be that could fix it, actually. And maybe what I will do is I will just do. Can I just do one iteration so I see how the whole thing looks like? Maybe that's the better. Yeah, maybe I should probably go through all the cells and now get this one to run. Once this is so circ is not defined. What is not defined, my friend? Circ is not defined. Where? In the apply fix assets? Circ is not defined, but I am applying. I am doing the. I am creating a circuit, am I not? Yeah, here it is. So what are you complaining about now? Is it that? Circ. Name circ is not defined. What's wrong? What? Just because I changed that to 1? How could I have possibly messed up with this? That was working. Come on. What is the problem? Calculate cost function. Here's circ. You can see this, right? Is this working actually? Yeah, it's working. Cool. You can see the circ. Why aren't you seeing that? Because maybe I should create this globally first. Somewhere, I guess. For this to be considered defined? Come on. Come on. If so, I'll be lame. So this is the worst programming. So this is the worst code ever, probably. Circuit with classical bits cannot be converted to gate. Okay. So why wasn't I getting those errors before? So I'm doing these. Something's really wrong here. I don't know. Circ to gate. And here I'm adding the actual. Okay, so here I'm creating the actual. How did this even work? Where? Ah. How did this even work? Where am I creating? Where is circ? Come on. I'm gonna get pissed now. What? What the hell is this? Let me just restart the whole thing. So. Oh, now it's working. So just doing like that, like 200 times, I guess. So can I just restart that and I'll put one iteration because I want to see how this works and where and whether those numbers make sense at all. Okay, so so these are the parameters used, I guess, right? I guess those are the parameters used, and then so the should should make my prints a bit more clear, to be honest. So what am I doing? What am I printing out? I'm printing out basically overlap R1. I think I can just do like this, right? In Python as well. So this would be overlap R2, and this would be basically what we're doing here is the so we're doing this, and this is for the cost, okay? And so so I guess here what we're doing is this. And here we're doing the same. So I'm basically adding these prints so I can just understand better what am I printing. It actually works. So, see, I'm printing wrong. I can only concatenate strings, not floats. Come on. So I'll just have to do it like this. Uh, 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 uh. I guess I'll have to just do it like this. And here, exactly the same. But this, okay. And so here we just want to get that print out as well. Time print. Okay. Wrong now. Where? Syntax error. My syntax error. Return. These and these. Okay, now. Okay, so overlap R1. Okay, so these is, so the overlap is 0 0.01, 0 0.01, and 1. So for each of the three for each of the these three elements. So what is overlap? R1 counts 1, counts 2, counts 3. Okay, so the three different circuits where we're measuring the three different, yeah. So we're comparing the three different qubits, right? Because we're using 3 qubits, aren't we? Not 4 or something, no, it's 3. Good. So it kind of basically means, because they are not all 1, I'll multiply them. So it's going to be the overlap R1 is going to be something small. Yeah, so it's going to be really, really small. So exactly. And because it's going to be something really small, and then we're doing R2, okay. So then we're doing R2. So then we're doing R2, aren't we? What am I printing in here? So many weird things. Again, R1, that's confusing. R2, okay, yeah. Yeah, sorry. So this would be, okay, so this is 4A. Should probably print here. Should probably print A1. print A2 and final cost. So A1, A2, and then the final cost. And so the final cost is really high. That makes sense. So it's wrong. Okay, so that makes sense. Now, the thing is, if I put in here, let's say, 100 iterations, right? I don't think it's going to change a lot, is it? Final cost keeps being the same. So it looks like this function is not really, it looks like this cost function is not really good. But I just wonder whether it's really working. And how could I know whether it's really working or not? To be honest, I'm getting the same all over again. There's no. It doesn't look like it's managing to minimize that. Why is that? Am I updating the parameters properly? Calculate cost function parameters. Parameters. I can print the parameters. So parameters. It's the same all over again. So what if I do just like 10? So the parameters 0.2, 2.9. Yeah, they don't vary a lot. Do they actually vary? It's a question. 0.29, 0.249, 0.249, 2921, 1313. Okay, here they do vary significantly. It's just one degree, right? Here 0.3, 1.3, 0.16, 0.16, 222. It's like the cost doesn't go down really. If I would just print the cost, it just stays the same. So it seems so either something's wrong or that as a cost function is not really effective. But I can't imagine why. I mean, the parameters are definitely varying. So the parameters are varying, but my cost is not, which is weird because I would expect those things to change. I mean, maybe so maybe I'm calculate cost functions parameters. So I'm putting the parameters in here. Apply fixed ansatz and apply fixed ansatz with these parameters. It's basically taking these parameters and applying them to this to circ. Should I just how do I make sure that's the right circ, the right circuit that I'm giving it to? Maybe there's something wrong there. So I create the circuit here, right? And so that becomes circuit, and then this just, yeah. Then apply, maybe, am I calling this correctly if I don't, like, maybe, maybe there's no, maybe there's no, uh, maybe that was not calling the function or something. That would be really stupid. That would be really stupid. Oh, that was a calling the function. That's so stupid. Oh my god. That's so stupid. Okay, now we're getting interesting things in here. The overlap is going down a little bit, I think. It starts with like 4 nines, right? 8 3. I mean, it ends, and here we were at like, yeah. But now it looks like it's working. I love Python. So that was, I was not calling the, I was not a call. So I was not doing an overlap test. So what was this just measuring? But I don't know. That was funny. So I was not applying any of these things. Interesting. So what if I become a bit less verbose? Uh, what about I do something like if verbose, and then like that? I just wanna be able to so the cost I definitely want to print anyway. Print. So these, I mean, so okay, so these these I just want to be able to print anyway. And the rest I'm gonna ignore. So I'm just gonna get this global thing in here that basically it doesn't print those things if I don't want it to, but it just prints the cost because I just want to go and see. Now I will say verbose false. Is it this way? And now let's do this. Okay, first let's try with 10. Yeah, that's working. Okay, cool. Seems like it's working, or at least it's moving something. So what if I give it like now 200? See where this goes. See where this goes. The cost is really high if I compare it to how fast it moves here. What are the results? Okay, it still jumps a lot. It still jumps quite a lot. And it gets to these cost. So what now? It's done or what? I don't get it. Oh, it's still printing. But why is it so slow? Come on. Anyway, it seems it's playing with this a little bit. I still don't know if I'm doing this in the right way. I'd like to try to see if I can print the circuit. As an example that it's actually the one that's actually being run. So maybe can just do it here, right? Because this is just minimize circuit. I just wanna. Okay, it's running. Can I add a cell above and say circ draw? Is it gonna draw me something? Or not? Because this is currently there's another cell executing. Okay. Do I stop it? Doesn't seem like it's going as down as I would like it to be honest. Yeah, I think I'll stop it. Interrupt the kernel. And we'll get rid of this cell by the way. So we'll just edit delete cells, and we'll go back here to one iteration, and we will basically see what the circuit looks like. Output. I have to go through everything again. I think so. Is it printing the circuit or not? Why not? So do I have to kind of now insert a cell above and do this myself? Okay, so what do we have here? So this is the actual so here we start with the ansatz. Here we end with the ansatz, and here, because this is really so this is one Hadamard test. Something's off, something's wrong in here. I can see that already. Because why are those Hadamard tests? So this is the overlap test. So that guy here, this is so this is A1, right? No, okay, I see. Okay. No, let me delete that. Can I delete that? Can I? Come on. It's not working. Yeah. These and these are B. This guy here is A1. And then, oh, come on, these, sorry. And then, so, and then these and these, but why, so my question is, why do I have these things appended here? I shouldn't have these things appended here at all. So this is a problem. This means it seems that it seems like it's, I don't know how it works. Let me just, maybe it's because I have this whole thing zoomed in here. Refresh. Can I refresh this? Just refresh that. So the problem here is because of what? So this circuit seems to have a bunch of funny stuff appended to it, and so it seems like for some reason this is not like overridden or something, because it's like it seems like I'm appending that to circ again. So what about I just do this properly and the apply. So all these functions maybe. So I will call this circ A. I will call this circ. So I'll give it two different names, circ A, circ B, and so I'm gonna use these. I'm gonna pass these things as a parameters, and then I'm gonna basically be I'm gonna be returning the circuit. Let's make sure that it's all. I'm sorry, I'm bad at these. I don't know why those things are just messing up with global variables and whatnot. And so, and this is going to be circ B. So, in the time to play with these, basically. Oh, maybe that's the reason why. Maybe that's the reason why there's this global something in here. Global circ. Oh, look at these. Ah, so this is maybe. Okay, so circ is. So the circ object is created inside the cost function and it's declared as global. Keyword. Global keyword allows you to modify the variable outside of the current scope. It is used to create a global variable and make changes to the variable in a local context. The basic rules of global keyword Python are: when we create a variable inside a function, it is local by default. When we define a variable outside of a function, it is global by default. You don't have to use global keyword. We use the global keyword, blah, 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 blah. But it kind of means that if I create the circuit in here, yeah, let me just not mess up with these. Let's just create two circuits. Let's just create two circuits, okay? And circ B, circ B, circ B. And so circ A also will go here, circ B will also go here, and there we go. And now I only need to just kind of like, this would be circ X, right? That's the circuit we're being given. And so we're creating those things here locally with measurements, blah, blah, blah. That's just a test. And so we'll call this circ X and replace everything by circ X. And we're going to return circ X. And we're going to do the same here. Return circ X. Do this. Just remember not to mess up with stuff. And so here, circ X is here. And so we're going to we're given the circuit and we're just returning it. Okay, so that's the idea. Let me just restart the kernel, just make sure we start clean, and we now go. We'll skip this one. Okay, cool. So now it's done here. Now circ should be empty, to be honest. Yeah, cool. But if I print circ A, yeah, that's not defined. Great. Uh, mm, how can I check that then? I guess I cannot draw. I think I cannot. I cannot click draw. I cannot call draw inside that method. I think it's not going to draw it. Um, mm, 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 mm. How do I make sure that this is the? So what if I do global, global? It's disaster. Global circ G. Okay. And so, and global circ GB and GA. And so I'm going to basically, at the end here, say circ GA equals circ A. And at the end here, I'm going to say circ GB equals circ B. And I'm going to just print GA first. I'll do this. That worked. Now we're gonna print this. Okay, now it seems to work. So this is just it hasn't really messed it up. The same here, right? So let's take a look at this quickly. Let's pick the painting tool. So up until here, it's so this is our variational part. I think it's like something has represented like this. This part in here is basically B. Now here I'm missing, there's no operation, there's no A2 because A2 is it's like the identity, and then we have one of the elements of Hadamard test, another one in here, and another one in here, so that works well. If I would print basically cert B, we cert GA, we would get that little Z in here exactly. Okay, so that's good. So that doesn't look that bad. Now it seems like okay. Let's give it a try with 200 now. Now it's going faster, and that's good, and that makes sense because the thing is, the circuit. I have the impression the circuit before was growing and growing, and that's why it was taking forever. Okay, but this is crap basically. So after 200, we haven't really found anything close to the the cost is so awful. Uh, what if I do like 1,000? 1,000? Do we even get down to like? Yeah, it needs way more. It seems like it needs way more iterations. Come on, we got a 0 in here at least, but like, oh man, like, can I do 10,000? Oh, wait a second, it stops. Oh, wait, why? Optimization terminated successfully. Success true. But why? The cost is it's really high. So what is the problem? I don't get it. So how is that? So how is that anyhow? Because this is getting close to 0. Success false, it says. Maximum number of function solutions has been exceeded. Fun. I don't get it. How can the function say, how can it say success true? So Kabila, minimize. Qiskit, minimize, Kabila. I mean, let's compare for a second the answers though. So I'm getting like this array, which is like starts with like 0.98. Yeah, those are not, those are far away from. Maybe it somehow converged and it stopped or something like that. Um, maximum iterations set to true to print conversions. Okay, so let's try conversions messages. Disp, max iter, copilla, last copilla max iter. So method copilla. Okay, minimize. Okay, no, but I want to. No, I want to minimize. Minimize. Message from minimize. What is it that we're using here? Oh, we're using SciPy, so we're not using anything from Qiskit. Minimize callable args method. Constraints, tolerance method. Okay, method. So I can still call it, I can still do these deep disp true. Set to 0. Status 1. Fun. Max CV. I guess it means it converged, which now the result. It's an optimized result. Status in. Refer to message for details. Message string. Yeah. Simulation successful. I mean, let's see. So let's try one thing. So let's do the following. Let's try to get the array and see what happens. So prints is here. So I'm getting out the array. I'm creating a quantum circuit. And then I'm basically applying circ f, I'll call it, and then I'll apply the ansatz for these parameters, then getting the backend state vector simulator, getting these, and we're gonna get the state vector and print O. Okay, with like 200. So we're doing all these, and then hopefully it's going to give us at the end. So this is the state vector. What is this? Is it just all zeros? Or what is that? I guess so. But if it's a 3 qubit, why does it have so many values? Am I stupid or what am I missing here? Get the state vector. Oh, sorry. Circ F. Maybe I just should keep these out into another cell so I can then so I can repeat that. Could not be found. What circuit could not be found? What are you talking about? Ah, I have to run this again. Okay. Okay. And now I do it like that. Get state vector simulator. What is the problem? Get state vector. Circuit F. Mm. 1, 2, 3, 1, 2, 3, 3. So, what is the problem now? Yeah. Okay, that now makes more sense. How can I? So let's do the following. So if I apply post processing to these, so if I apply, let's say, be an overlap test, right? Let's say that I do these. Just want to check. What time is it, by the way? Okay, I think it's about time. Ah, man. This seems all right. Calculate cost function. Well, I can actually just call that, can I? I can just call that, to be honest, and get what I want. That's what I just wanted to. I wanted to check. That's kind of fine, but I wanted to just basically say no. So this is giving me these, and what I wanted to try is in another cell maybe calculate cost function of our f. So these parameters. No, no. Not out F, but just out. Hashable type slice. What the heck? Out is these, right? Oh, out X, sorry. This is what we want. That's a really high cost. That's not. That's stupid. Okay, so it's either I'm doing something wrong when I really have no idea, or the this is simply just the wrong optimizer, maybe, for that type of cost function. It's like I'm not really familiar with cost function theory anyway, so I don't know if, at the end of the day, the choice of, that just, it's a type of cost function that doesn't work well with this optimizer. Because what, there's no gradient or something? You know what I mean? Because it's a it's a cost function. So the cost function is basically the result of the Hadamard overlap test, right? But seems to me it should work. Maybe let's try another optimizer. What other optimizers have we got in here that we can use? I have no idea. I guess I can just do that. See if it somehow works better. I can't seem to get past like terminate successfully, but I can't seem to get past the 0.94. So now the question is always obviously whether this is something wrong with the way I calculate the cost. Let's put it this way. I know the solution. Let me see what cost my function. Oh, yeah, let's do that. So I know this solution. Okay. Yeah. So this gives you like, okay, so let's try this. So I've got here a solution. Okay. And if I do this Come on. Okay, so there's something wrong with my. Okay, so there's something wrong with the way my cost function works, because that solution should work. Because that solution should definitely work, and it gives me a cost that's really high. Okay, so that's going to be okay. So I'm gonna do that as my next word. So there's something off in here. So get the parameters, and let me print if I've done this now, and now so I do this, and I now do circ GA draw output PL, and I do the same for GB. Circ. So we're yeah. So those are the parameters basically. And then the Z gate. Remember that here the circuit it's got all the controls and whatnot in here, so you would actually have the Z in there. So you would have the Z, like, yeah, that's the Z in here. That's the Z in here. Okay. So yeah, but that's why I'm even. So this should actually give me a low cost. The overlap there should give me a low cost. Maybe I'm not calculating that correctly. Maybe I'm not calculating that correctly. So what am I doing? I'm doing take the parameters, I'm doing the quantum circuit, I'm applying the answers, blah, 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 and apply the overlap test. So maybe this is what I should check out. Apply overlap test. Where is that function written? Oh no, that's the actual test. So what we want to take a look is at the post-processing method. That calculates me the overlap of this component. And then what am I doing? I'm adding the overlap. So maybe I'm getting this wrong. So if the overlap, maybe I'm getting this wrong. Maybe if the overlap is 0, if the answer is 0, it means the overlap is. So where's that paper? How I even get there? Just do a quick example. So we want to compare two qubits. I want to compare them both. They are both in the state plus and plus. So we want to do a these, and then take a look at the chances. Yeah, it's already 0. No. Wait a second, it's 1. Because this plus this is 1. 0 0.5, 0 0.5 is 1. So when they are equal, they are 1. When they are completely different, then it's 0, exactly. And we want, okay, no. And we want these to be 1 minus the overlap. Because if the overlap is, no, if the overlap, we want them equal. If the overlap is equal, we have an overlap of 1. So if the result is equal, exactly. f of 1. And so on 1 minus 1. Yeah, that's correct. Overlap 2. So, and in the way this post-processing works is we're comparing the two pairs, but then maybe I should I multiply them? I guess so, right? So we're for I in counts 1, if I equals 11, then counts 1. 11 divided by 1,000, because we're doing this 1,000 times, minus if no, then we're adding these. It's got to be somewhere here, so maybe there's a mistake in the way this is calculated, but I'll figure it out next time. Anyway, that was good. But okay, so these at least tells me there's something off with my, because these solutions should actually give me a low cost on my side as well. I mean, regardless of what I'm doing, that solution should kind of give me a low cost. Cool. See you next time.